You know that feeling when something's wrong, but everyone pretends it's fine. It's a quiet hum in the back of your mind, a dissonance you can't quite resolve. That's 3i Atlas. For 2 solid years, astronomers have meticulously catalogued anomaly after anomaly, each new oddity met with increasingly elaborate and creative explanations from the scientific establishment. Each time, the community nodded, filed it under interesting but not paradigm-shifting, and moved on. But then December 2025 arrived, and with it came images that cannot be hand-waved away, data that refuses to be folded into our comfortable understanding of the cosmos. The images showed a sunward beam, not a gentle fan or a diffused spray, but a stark geometric line of light and energy, stretching farther than the distance from the Earth to the Moon, maintaining a columnation, a focused, parallel-sided structure that natural gas expansion in a vacuum simply cannot produce. This wasn't just another quirk, this was the 15th strike against the simple comet hypothesis. Think of it this way: 1 improbability is a curiosity, 2 are a coincidence, but 15 improbabilities, when multiplied together, cascade into an effective impossibility. The math becomes a wall. I want you to stay until the very end of this, because we're not going to just glance at this mystery. We're going to walk methodically through every single natural explanation that has been proposed, from the mundane to the exotic. We will watch them crumble, one by one, under the uncompromising weight of basic physics and observational geometry, and then we will be forced to face what's left standing in the rubble. It won't be a comfortable conclusion. It will challenge foundations, but it might, just might, be true. If the anomalies surrounding 3i Atlas have pulled you into their gravitational well, the way they have relentlessly pulled me these past months, then make sure you subscribe to this channel. Don't miss what comes next as this object, this silent traveller, continues its irreversible journey out of our solar system and into the black, taking its secrets with it. As you listen, leave a comment down below. Tell me where in the world you're watching from, what time it is in your corner of the globe right now. Is it the dead of night, the break of dawn? And give me your honest take. Do you believe we, the public, are being told the complete and unfiltered story about this interstellar visitor? The 15th anomaly, the moment randomness died. It began with a silence. Not the peaceful quiet of empty space, but the stunned, heavy silence of a room full of experts who have just seen the impossible materialize on their screens. In December 2025, astronomers at the European Southern Observatory's flagship facility were conducting what was supposed to be a routine tracking session of the interstellar object designated 3i Atlas. The protocol was standard, the motions rote. Then their instruments captured something that froze the routine dead. A beam. Let's be perfectly clear in our language. This was not a tail. It was not a plume. It was not some amorphous, diffused cloud of particles doing what comets have done for eons. This was a beam. Columnated, persistent, geometrically precise to an unnerving degree, pointing directly at the heart of our solar system, like a rifle barrel forged from light and energized plasma. To understand the sheer revolutionary disruption of this image, you need to first understand what comets are and what they do. Comets are cosmic messes. They're often called dirty snowballs, but that term almost sanitizes their chaos. They're aggregates of ice, dust, and rock that have been wandering in deep freeze since the birth of their parent system. When they swing close to a star, solar radiation begins to heat their surfaces. Ice doesn't melt in the vacuum of space, it sublimates, turning directly from solid to gas. This process is violent and uneven. Jets of gas and dust erupt from fissures and vents, spraying out in chaotic fan-shaped patterns. The released dust, pushed by the gentle but constant pressure of sunlight, forms the iconic curved dust tail. The ionized gas, glowing under the sun's ultraviolet light, forms the straighter, bluer ion tail. But crucially, both tails point away from the sun, and both spread out, they diffuse, they expand, because that is what gas does when released into a vacuum. There is nothing to contain it, no atmospheric pressure to fight against. The molecules, energized by heat, fly apart in all directions from their source point. The technical term is isotropic expansion, equal in all directions. A comet's coma, the cloud around its nucleus, is a fuzzy, growing sphere. Its tails are streaming, dispersing cones. They do not, They cannot form a narrow, straight columnated beam that holds its shape across astronomical distances. Now, let's look at what the December data showed. The anomalous feature extended from the nucleus of 3I Atlas roughly 500,000 kilometers into the void. To grasp that scale, hold this in your mind. The average distance from the Earth to the Moon is about 384,400 kilometers. This beam was longer than that entire lunar journey. You could take the Moon's orbit around our planet and fit it neatly inside the length of this structure. That alone is staggering. But it's the geometry that shatters the comet model. Across that immense, continental dwarfing length, the beam maintained an almost impossibly narrow angular width of only 6 to 8 degrees. Do the trigonometry or just trust the result, and that translates to a physical width at the beam's far end of roughly 50,000 to 70,000 kilometers. Still vast, yes, but incredibly narrow for something that originated as presumably sublimating ice and travelled 250,000 miles. This is not mostly straight. This is columnation. This is focus. This is the kind of disciplined, tight geometry we associate with engineered systems, with lasers, with particle accelerators, with directed energy devices. It is not the signature of a lump of ice haphazardly vomiting gas as it tumbles through space. The team, with a mix of dread and exhilaration, labelled it the 15th anomaly, not the 15th in a chronological list, but the 15th distinct, categorically weird characteristic of this object that steadfastly, defiantly refuses to behave as any natural celestial body in our catalogues ever has. This is critical. We are not discussing a pile-up of measurement errors or a suite of instrumental glitches. This is not an artifact of a single telescope's optics or a software bug in one pipeline. Multiple independent observatories, using different instruments and different observation techniques, have now confirmed the existence and structure of this beam across multiple windows of time spanning several days in mid-December. It is real, it is persistent, and it is pointing at our sun with a targeting precision that should send a chill down the spine of anyone who understands the physics involved. Avi Loeb, the Harvard astrophysicist who has been the most prominent and vocal scientist tracking this object since its discovery, distilled the situation with characteristic bluntness in his latest published analysis. We are past the point of cataloguing anomalies. We are at the point where probability itself collapses. His argument is statistical, but it's built on a mountain of data. When you have not one or two but 15 independent characteristics, each one deviating significantly from the expected behaviour of a natural comet, you are no longer looking at a weird member of a known category. You are looking at an object that belongs to a different category entirely. The cumulative probability of all these anomalies occurring together by pure chance approaches 0. We will delve into that math later, the sobering 1,000,000,000 to 1 odds. But first, you must understand why this beam, in and of itself, is a fundamental violation of known cometary physics. Let me be unequivocal. No one involved in the serious analysis is claiming 100% certainty of an artificial origin. That is not how science works. What is being claimed, with growing confidence, is that the entire toolkit of natural explanations we have at our disposal, every mechanism in the textbooks, every published paper on cometary outgassing, every model of sublimation and jet formation, fails to account for what we see. They don't just struggle, they fail comprehensively. And when every natural explanation you can conceive of fails so utterly, science is left with a profound and deeply uncomfortable obligation to ask the next question. If it's not natural, what else could fit the data? We are going to walk through, step by step, exactly why this columnated sunward beam is incompatible with the known behaviour of comets. We will examine every single mechanism that has been proposed, from anti-tails to magnetic confinement to exotic vent geometries, and we will watch them fail, one after the other, buckling under the straightforward laws of thermodynamics, gas dynamics, and geometry. Because the truly haunting thing about 3I Atlas isn't that it has one bizarre feature. It's that the object presents a coordinated suite of puzzles where every attempted fix for one anomaly makes the other anomalies even harder to explain. Trying to force 3I Atlas into the comet box doesn't just require bending the rules. It requires breaking them, then inventing new ones, then stacking improbable coincidence upon improbable coincidence. The more desperately we try to make it fit our old models, The more contrived and unbelievable those models become. There comes a point, and many of us believe we have now reached it, where the natural explanation becomes a far more extraordinary claim than the alternative we've been so diligently avoiding. The beam was not a fleeting ghost. It appeared in multiple calibrated exposures taken between December 9th and December 15th, 2025. It did not flicker like a flare from an energetic event. It was not a smudge or a streak created by stacking and processing images. It was there, solid and unambiguous, its geometry and orientation locked in place across observation windows separated by days. This persistence tells us something vital. Whatever is producing this emission is not a momentary burp or an episodic eruption. It is a sustained, controlled emission with a directional stability that comets categorically do not possess. When comets experience outbursts, they spray material in arcs and fans dictated by the chaotic interplay of their rotation and the specific locations of active vents on their irregular surfaces. The activity pulses and fades. It does not produce a steady, laser-like beam that holds its aim for days on end. The sunward orientation is perhaps the most immediately jarring aspect for any astronomer. All conventional comet physics dictates that tails point away from the sun. Solar radiation pressure, the literal push of sunlight, acts on small particles and molecules driving them outward. There is a known phenomenon called an anti-tail, which can appear to point toward the sun, but it is a classic illusion of perspective. It occurs when Earth passes through the orbital plane of a comet's debris trail. We see the thin edge of the disk of dust, which can project as a spike pointing sunward. But the particles in that anti-tail are still physically moving away from the sun. We're just seeing the edge of the sheet. It's an optical trick. What we are seeing with 3i Atlas is not an anti-tail. The geometry of its orbit and Earth's position don't align for such an illusion during the observation period. More importantly, anti-tails are diffuse, short-lived, lasting hours to maybe a day as Earth's geometry shifts, and they fan out. They do not persist for 6 days. They do not maintain a constant narrow columnation across 500,000 kilometers. So we are left with a structure that, according to all our textbooks, should not exist. Yet it was photographed, repeatedly, by world-class instruments. It has survived rigorous independent analysis. It exhibits characteristics that have no natural analogue in the entire history of cometary science. This is the 15th anomaly, and it forces upon us the question that whispers in the halls of every astronomy department, but is rarely spoken above a murmur in public. What happens when the merely improbable crosses the threshold into the effectively impossible? What do we do when every door labelled natural explanation is opened only to reveal a solid brick wall behind it? Do we keep insisting, with increasing volume, that it must be a comet simply because comets are the only thing we know, the only box we have? Or do we, with great trepidation, begin to seriously consider the possibility we have been trying so very hard not to consider? That maybe, just maybe, in December of 2025, the reign of pure randomness in our cosmic neighbourhood ended, and we found ourselves not as solitary observers, but as the observed. Let's talk about anti-tails for a moment, because that's the first refuge, the initial safe harbour any reasonable astronomer runs to when they see something in the data that appears to point toward the sun. Anti-tails are well-documented optical illusions, a kind of cosmic sleight of hand. They occur when Earth's viewing angle aligns almost perfectly with the orbital plane of a comet. From this precise edge-on perspective, the comet's broad, curved fan of debris, which is physically stretching away from the sun, gets projected onto the two-dimensional sky as a narrow, bright spike that seems to point back at the sun. Think of it like looking down a long, curving highway from exactly the right hilltop. The road can appear perfectly straight, even though you know it bends. The effect is visually striking but physically mundane. The particles creating that anti-tail are still obeying all the normal rules. They are being pushed by solar radiation pressure. They are following orbital trajectories dictated by gravity and momentum, and they are most definitely moving away from the sun. The illusion is purely geometric, a trick of the line of sight. It's real in the sense that the photons are really there, but the underlying reality is conventional cometary behaviour. The problem, the insurmountable problem for 3i Atlas, is that anti-tails have a specific set of signatures. They are, by their very nature, diffuse. Because you are looking through a thin sheet of particles, the edges fade smoothly. They are ephemeral, lasting only for hours or perhaps a day, as Earth's motion changes the viewing geometry and breaks the precise alignment. They show a characteristic fan-shaped or conical spread when analysed with sensitive instruments, because you are seeing a three-dimensional cloud of particles projected onto a plane. The particles that are farther from your exact line of sight appear dimmer and more spread out. Most importantly, antitails are not columnated. They might appear narrow at a quick glance in a single image, but detailed photometric analysis always reveals they are widening cones. The December 2025 beam from 3i Atlas shows none of these diagnostic characteristics. It persisted, bright and unambiguous, for at least 6 full days across multiple separate observation windows. It maintained that razor-sharp angular columnation of 6 to 8 degrees across its entire monstrous length of 500,000 kilometers. It showed no significant fading or spreading at its far end. The beam's edges remained sharp and defined against the black of space. These are not the properties of an antitail. They are not the properties of any known cometary emission mechanism ever recorded in the annals of astronomy. This is where the physics gets deeply uncomfortable, where the easy answers stop and the hard questions begin. Let's state a fundamental law of gases in a vacuum. Gas does not naturally columnate itself in space. When you heat ice on a comet's surface, it sublimates directly into gas. That gas, now free from the solid, immediately expands into the surrounding vacuum, and a vacuum is the ultimate medium for expansion. There is no ambient air pressure, no atmospheric confinement, no container walls to push back. The newly liberated gas molecules fly apart in all directions at thermal velocities determined by their temperature. For water vapour sublimating from a comet near the Sun, these velocities are on the order of several hundred meters per second. From a point source, they create an expanding sphere of gas. The physics term is, again, isotropic expansion, equal in all directions. Now, do comets produce jets? Absolutely. When sublimation is concentrated in a crack, fissure or vent, the surrounding solid material can act as a nozzle, channeling the initial flow and giving it some directionality. We see these jets on comets like 67P Churyumov-Gerasimenko, photographed in stunning detail by the Rosetta mission. But here is the critical distinction. Even those beautifully defined jets spread out rapidly once the gas escapes the confines of the surface vent. A typical cometary jet might maintain some coherent directionality for a few hundred, maybe a few thousand kilometers. After that, the combined effects of thermal molecular motion, each molecule jostling randomly in addition to the bulk flow, and the slight but persistent push of solar radiation pressure, smear the jet into a diffuse widening cloud. We have decades, now almost a century, of high-resolution observations of cometary jets. We know what they look like. They are elegant, but they are messy. They do not and cannot maintain tight columnation across distances measured in hundreds of thousands of kilometers, distances that dwarf entire planets. The sheer scale forbids it. Let's dwell on what columnation actually means at this astronomical scale. A 6 to 8 degree angular width over 500,000 kilometers. If you do the trigonometry, and I'll spare you the detailed equations, it means the beam maintains a physical width of roughly 50,000 to 70,000 kilometers at its terminus. That is still narrow. That is astonishingly, unnervingly narrow for a phenomenon that supposedly started as simple sublimating ice, and then travelled a distance greater than that from the Earth to the Moon. The effective expansion angle is so infinitesimally small that you would need some kind of active, continuous confinement mechanism to counteract the natural, explosive tendency of gas to spread. In human technology, we achieve such columnation using precisely ground lenses, carefully aligned mirrors, or powerful electromagnetic fields to shepherd charged particles. Comets have none of these things. They are lumps of rock and ice. They possess no optics, no magnets of the required strength, no engineered nozzles. Some researchers, straining for a naturalistic explanation, have tentatively proposed that solar radiation pressure itself could, under incredibly specific and contrived conditions, sculpt a sunward plume into a beam. The idea is that photons from the sun, scattering within a dense cloud of particles, could theoretically create a complex radiation pressure gradient that somehow pushes particles back toward the nucleus, creating a focused structure. But this idea collapses under scrutiny for multiple fatal reasons. First, and most fundamentally, solar radiation pressure pushes particles away from the sun. Photons carry momentum outward. They do not pull, they push. Creating a net inward pressure gradient would require a geometry of scattering and re-radiation that is not just unlikely, but arguably physically impossible in a tenuous cometary coma. Second, even if such a perverse gradient could be conjured in a model, it would be dynamically, violently unstable. The slightest asymmetry, the tiniest perturbation in the cloud, would destroy the beam structure instantly. Nature abhors such perfect, unstable configurations. Third, and decisively, we are talking primarily about gas here, not just dust. Radiation pressure on individual gas molecules is negligible compared to their own high thermal velocities. The molecules would ignore the faint photon push and spread out due to their own heat long before any beam-shaping effect could occur. What about magnetic fields? Could a comet somehow generate or focus a magnetic field strong enough to channel ionized gas into a narrow collimated beam? The answer is a resounding no for several concrete reasons. Comets are not magnetized bodies. They do not have molten metallic cores, internal dynamos, or the compositional and structural prerequisites to generate significant intrinsic magnetic fields. Any magnetic field in their vicinity is usually the result of the solar wind's magnetic field draping around their coma, a weak, messy, and external effect. Even if a comet could somehow possess a strong magnetic field, the density of gas in a cometary coma is far, far too low for magnetic confinement to work. Magnetic confinement requires high particle densities and immensely strong fields to overcome the particles' kinetic energy and force them to follow field lines. This is why our most advanced nuclear fusion experiments like tokamaks require building-size superconducting magnets drawing massive amounts of power. A comet is a frozen, primitive body, not a miniature tokamak reactor. The required energies and field strengths are off by orders of magnitude that span the gap between a campfire and a supernova. The sheer scale of this beam is also a critical data point that is often overlooked. We are not discussing a microscopic feature requiring the most powerful telescope to resolve. 500,000 kilometers is a macroscopic planetary-scale structure. If this beam existed anywhere near Earth, it would be blatantly obvious to amateur astronomers with backyard telescopes. The fact that it maintains coherence, a consistent shape and direction, across this staggering distance means that whatever process is creating, it is not a brief explosive event. It has sustained, consistent energy input. It is being fed. And this is where the natural comet model faces another devastating contradiction. Cometary sublimation is intrinsically episodic and chaotic. It depends on solar heating, which varies wildly as the irregular nucleus tumbles, rotating dark cold sides into sunlight and hot active sides into shadow. Surface features evolve, vents open and close as material is ejected. You do not get a sustained, geometrically stable emission, lasting days from a tumbling, unevenly heated ball of ice. The output flickers, pulses, and changes direction. 3I Atlas's beam did not. There is also the profound problem of energy and momentum. Maintaining a columnated beam across these distances requires either an enormous initial ejection velocity, so high that the particles travel in a nearly parallel stream before spreading has time to occur, or a continuous acceleration mechanism that acts along the entire beam to keep it focused. If the gas was simply ejected at high speed from a vent, it would still spread due to the innate thermal motion of the molecules. Each molecule has a random thermal velocity vector in addition to the bulk flow direction. Over a distance of 500,000 kilometers, these random motions would smear even an initially tight jet into a wide cone. To keep a beam as tight as we observe, you would need some mechanism that continuously corrects for this thermal expansion, that actively shepherds wayward molecules back into the formation. You would need, for all practical purposes, an active guidance system. You would need something that looks suspiciously like a focused thruster or a particle accelerator. Every single natural mechanism we can conceive of, sublimation jets, radiation pressure sculpting, magnetic confinement, explosive outbursts, fails on at least one critical physical point. Most fail on several simultaneously. The beam is too narrow for natural isotropic or even mildly directed expansion. It is too persistent and stable for an anti-tail or any other transient illusion. It is pointing in the wrong direction for radiation pressure to be the driver. It operates at a scale and energy level that rules out small-scale venting or localized phenomena. We are not cherry-picking one problematic characteristic here and ignoring others that fit. We are looking at a devastating convergence of impossibilities. Each natural explanation we try to insert into the equation collapses under its own weight when held against the basic, well-tested laws of physics. But as staggering as this beam is, as fundamentally inexplicable as it appears within our current paradigm, it is not even the strangest part of the 3i Atlas story. The beam is merely one glaring symptom, one manifestation of a deeper, more systemic problem, a problem of geometry, of symmetry, a problem that elevates the odds from merely astronomical to philosophically absurd. Because 3i Atlas didn't produce this impossible beam from just one location, it produced it from two, from opposite poles, at different times, with identical characteristics, and that is when probability doesn't just become small, it becomes a deafening roar of impossibility. This is the part where hand-waving stops. Perihelion, the point in an orbit where an object makes its closest approach to the Sun, is the moment of truth for any comet. For 3i Atlas, perihelion occurred in January 2025, when it swung through the inner solar system at a distance roughly equal to Earth's own orbit from the Sun, one astronomical unit. It got warm, and like any comet presumably would under such an onslaught of solar radiation, it began to outgas. Early observations confirmed activity. We saw jets, we saw a coma, we saw the expected signs of an icy body responding to stellar proximity. Careful analysis of that pre-perihelion activity revealed something interesting. The emission seemed to originate from a specific, localized region on the object's surface. For simplicity, let's call this region the North Pole, though the orientation is arbitrary. What mattered was the consistency. The activity was coming predominantly from one end of the object. The geometry of the emission, while strange in its precision even then, was anchored to that pole. Then 3i Atlas passed its moment of greatest solar intimacy and continued on its unstoppable hyperbolic trajectory, arcing back out into the frigid depths of the solar system. Solar heating should have decreased. Activity should have declined, fading as the ice retreated into dormancy. Standard comet story. But that is not what happened. Instead, starting in late November 2025 and continuing powerfully through the critical December observations, astronomers witnessed renewed activity. Not just renewed, but stronger, more defined. And the geometry had undergone a profound transformation. The emissions were now coming from the opposite pole, the same type of impossibly columnated beam, the same 6 to 8 degree angular width, the same sunward orientation, the same persistence. But now its source was rotated 180 degrees from the location observed before perihelion. The object had effectively switched which end was active. It had turned off one impossibly precise cosmic searchlight and turned on another, identical one, on its opposite side. Now comets do have rotational axes. They spin, and as they travel along their orbits, different hemispheres receive different amounts of solar illumination. It is entirely possible, even expected, for activity to shift from one region to another as the seasons change on the comet's surface. A vent that was sunlit and active on the inbound journey might fall into shadow on the outbound leg, while a previously shadowed region might thaw and become active. This is basic cometary science. But here is the problem that shatters the simple seasonal shift explanation. For both poles to produce not just activity but identical beam characteristics, you need far more than just a change in solar heating. You need perfect symmetry. You need both poles to possess not just some volatile ice, but the same exact subsurface structure, the same thermal properties, the same gas reservoir composition and pressure, the same vent geometry, and the same emission physics. And you need them to activate at precisely the correct orbital moments, like a perfectly choreographed cosmic ballet. Think about what this demands from a naturally formed object. First, you need the North Pole, during its active period approaching perihelion, to develop or to already possess a feature capable of channeling gas into a 6 to 8 degree columnated beam that points with laser-like precision at the Sun. As we established in the previous section, this is already a physical implausibility of the highest order. But let's grant it for the sake of argument. Let's say, through some freakish confluence of geology and physics, the North Pole of this wandering iceberg somehow formed or eroded into a natural gun barrel that could produce such a beam. Now, you need the South Pole, which is completely inactive, frozen and in shadow, during the entire time the North Pole is active, to possess an identical feature. Not a similar one, identical. Because the beam characteristics observed post-perihelion from the South Pole match the pre-perihelion beam from the North Pole, within the margin of observational error. Same collimation angle, same persistence over days, same intensity profile across its length. But the absurdity deepens when you consider thermal evolution. The North Pole was active when the object was approaching a near perihelion. It was receiving sustained, intense solar heating. It was sublimating, eroding, changing. Surface layers were being blasted away, vents were potentially widening. The very geometry of the emission source was dynamically evolving. The South Pole, during this entire tumultuous period, was in deep cold shadow. It was dormant, pristine, and presumably insulated by a layer of dust or depleted material. Then, after perihelion, the orbital geometry flips. The North Pole, recently active, presumably depleted of near-surface volatiles and altered by erosion, goes quiet. The South Pole, which was cold and untouched, suddenly awakens and, without any trial and error, without any gradual development, immediately produces an emission with characteristics identical to the North Pole's mature beam. How does the South Pole know what geometry to produce? How does it replicate a specific complex emission pattern that the North Pole developed under a completely different thermal history? Natural processes do not have memory. Ice sublimates where it is heated. Cracks propagate where mechanical stress concentrates. Erosion happens where the energy flux is highest. There is no physical mechanism, no communication, that allows one hemisphere of a rotating inert body to coordinate its activity with the opposite hemisphere to produce mirrored results. Yet here we have coordination, we have mirrored behavior, we have geometric matching that would be extraordinary if we were merely talking about simple diffuse jets. But we're talking about columnated beams that defy natural explanation in the first place. The mirroring of impossibility multiplies the impossibility exponentially. Let's talk about the statistical weight of this dual pole phenomenon. If we are generous, wildly, implausibly generous, and say the probability of one pole naturally producing this specific beam geometry is 1 in a million, then the probability of both poles independently producing identical geometry is 1 in a million squared, 1 in a trillion. And that's before we account for the timing, which is not random. The North Pole activated before perihelion, precisely when it was the sunward-facing hemisphere. The South Pole activated after perihelion, precisely when it rotated into the sunward position. The activation timing follows solar orientation with flawless logic. The beam geometry matches perfectly. The collimation matches perfectly. These are not independent coincidences piling up. This is correlated, intelligent-looking behavior. In human engineering, when you see two independent systems produce identical outputs under specific triggering conditions, you infer a common design. You infer that both systems were built to the same blueprint, programmed with the same response protocols. In nature, when you see identical behavior from two separate features, you look for a common physical cause, a shared aquifer, a uniform layer of material, a symmetric stress field. But 3I Atlas, if it is a natural comet, does not have a shared subsurface reservoir connecting its opposite poles. It is presumed to be a solid, cohesive body. The poles are thermally and structurally independent over the timescales involved. They have experienced billions of years of separate histories since accretion. The thermal insulation paradox makes this even worse. For the South Pole to remain completely inactive and pristine during the North Pole's fiery activity near the Sun, it likely needed to be well insulated. Comets often develop a crust of dust and refractory material on their sunlit sides, which can actually protect subsurface ice. But if the South Pole had such a thick protective crust that prevented any sublimation during the approach to perihelion, how does it suddenly activate with full, dramatic intensity the moment it rotates sunward? Insulation doesn't magically disappear because the sun angle changes. If the surface layer was thick enough to prevent activity during the hotter approach phase, it should still be there, still insulating, during the cooler departure phase. Yet the South Pole doesn't just sputter to life, it turns on like a switch, producing a fully formed sustained beam. The timing precision is also deeply troubling. The South Pole's activity didn't gradually ramp up as its surface slowly warmed. We didn't see sporadic outbursts or irregular jets as hidden ice pockets began to sublimate. The observations show sustained, geometrically stable emission beginning in late November and continuing through December. The beam appeared, in the data, fully formed. Its columnation was already established from the first moment it was detected. This is not how natural sublimation unfolds. You expect to see a feature develop, to see the emission strengthen, focus, and stabilize over time as a vent clears and establishes a flow. Instead, we see what looks unmistakably like an activation, like a system powering on. Avi Loeb's probability analysis incorporates this dual pole symmetry, and it is one of the heaviest factors in his calculation. Because even if you could, through heroic mental gymnastics, explain one beam as some bizarre once-in-a-galaxy confluence of unlikely surface features and thermal conditions, you cannot explain two. You cannot explain why a randomly accreted body, tumbling through the interstellar void for potentially hundreds of millions of years, would have evolved identical precision geometric features at opposite poles that then activate in perfect sequence as it passes through our solar system. The stacking of coincidences has reached a level where insisting it is all just coincidence becomes, itself, the extraordinary claim. Natural objects have a symmetry, they have irregularity, they have unique scars from their formation and evolution. When you see perfect functional mirroring, you're not looking at the hand of nature. You see intent, you see manufacturing, you see design. And maybe that's wrong. Maybe there is some exotic, undiscovered branch of comet physics that produces dual-pole columnated emissions. But if so, we must explain why we have never seen a hint of it in the thousands of comets we have observed in our own solar system over centuries. We must explain why it is showing up in pristine perfection on an interstellar object that is already violating a dozen other expectations. At some point, the simplest explanation, the one that requires the fewest independent miracles, stops being that nature got unbelievably creative. The simplest explanation becomes that we are looking at something that was built 1 in 4 billion. That is the number Avi Loeb's team calculated for the probability that 3i Atlas exhibits all of its 15 anomalous characteristics purely by random chance. 1 in 4 billion. Let me help you understand what that number actually means, because human brains are not built to intuitively process odds of this magnitude. If you bought a lottery ticket every single day for 10,000 years, for the entire span of recorded human civilization, your chances of winning a major jackpot would still be better than the odds of 3i Atlas being a naturally occurring comet. This is not merely unlikely. This is effectively impossible within the realm of reasonable scientific discourse. The calculation works by stacking independent probabilities. Each anomalous characteristic of 3i Atlas is assigned its own probability of occurring naturally based on historical data and physical models. The object's trajectory, for instance, is aligned with our solar system's ecliptic plane within a mere 2 degrees. Interstellar objects should arrive from random directions in the three-dimensional galaxy. The probability one would come in so perfectly aligned with our flat planetary disk is roughly 1 in 100. Then there's the acceleration anomaly, tiny deviations in its path that cannot be explained by gravitational tugs or standard rocket-like outgassing effects. Maybe a 1 in 50 chance. Unusual spectral signatures suggesting non-solar system-like compositions. Perhaps 1 in 20. Each of these individually is strange, noteworthy, but not impossible. Astronomers could shrug at any one of them, but here is the statistical key that changes everything. When multiple independent unlikely events all converge on the same object, you multiply their individual probabilities together to find the chance of them all happening together. Walk through this slowly. Imagine flipping a coin. Getting heads is a 1 in 2 chance, not remarkable. Flip 2 coins and get heads on both. 1 in 4, still mundane. Flip 10 coins and get 10 heads in a row. That's 1 in 134. Now you're raising eyebrows, something feels off. The probability of getting heads on 20 consecutive flips is about 1 in a million. At 30 consecutive heads, you're at 1 in a billion. And at that point, you would be absolutely correct to suspect the coin is rigged, that the game is not random. That is precisely what is happening with 3i Atlas. The object is showing us 30 heads in a row, 15 distinct heads against the expected tails of normal comet behavior. And we are being told by official channels that it's just a regular coin. A bit lucky, perhaps. The dual pole beam geometry alone contributes a massive crushing weight to this probability stack. Let's be conservative, excessively so, and say the chance of one pole naturally producing a perfectly columnated 6 to 8 degree sunward beam is 1 in 10,000. Given everything we know about comet physics, that is a wildly generous estimate. The true odds are likely far worse, but let's use it. The chance of the opposite pole independently producing an identical beam is another 1 in 10,000. Multiply those, 1 in 100 million, just for the beam symmetry. Now add the timing. Both beams activate precisely when their respective poles are facing the sun. Maybe that's a 1 in 10 chance for each pole, assuming some seasonal effect, so 1 in 100 for the coordination. Already, just for the beam characteristics and their activation timing, we're at 1 in 10 billion, and we haven't even factored in the ecliptic alignment, the anomalous acceleration, the strange composition, the low dust-to-gas ratio, the unusual rotation state, or the other 11 anomalies. The ecliptic alignment is perhaps the most statistically profound factor after the beams. Our solar system is fundamentally flat. The planets, most asteroids, and the vast majority of orbiting debris lie within a thin disk called the ecliptic plane. Interstellar space, however, is a three-dimensional sphere. Objects arriving from other star systems should have no preference for our particular plane. They should come from all angles, from above the ecliptic, from below it, from every direction on the celestial sphere. The probability that a random interstellar trajectory would lie within a narrow band of just 2 degrees of our ecliptic is the ratio of that tiny band's area to the area of the entire celestial sphere. That's roughly 1 in 100, maybe 1 in 200, depending on the exact tolerance. But 3i Atlas didn't just happen to be in the plane when we saw it. Its entire hyperbolic trajectory is coplanar with our solar system. It came in along the ecliptic, passed through perihelion, and is leaving along the ecliptic. This is the trajectory you would choose if you were designing an object to efficiently survey a planetary system. It maximizes the time spent in the plane where all the planets, asteroids, and concentrated solar wind effects are. It is the optimal path for sampling the environment of a star system. A random piece of interstellar debris has no reason to care about our ecliptic, but a probe would. Loeb's calculation is intentionally conservative. He excludes factors that are harder to quantify precisely, but point in the same direction. The object's unusual brightness variations that suggest a non-random, possibly manufactured surface. The peculiar lack of a significant dust coma relative to the powerful gas emissions. The fact that it was discovered just as our survey capabilities matured to the point of being able to detect such objects. These are all additional whispers of artificial, but they are left out of the main math to avoid criticism of overreach. The 1 in 4 billion figure is, if anything, an understatement. A common retort to astronomical improbabilities is the sheer scale argument. Space is big. Weird things happen. And that is undeniably true. The galaxy contains hundreds of billions of stars. Over billions of years, even 1 in a billion events should occur somewhere. But here's the crucial, often missed point. They should occur somewhere, at some time, to someone else. The relevant probability is not whether a weird object exists in the galaxy, but whether we would be the ones to find it, and find it now, in our tiny bubble of space and time, with our nascent observational capabilities. If 3i Atlas were a natural 1 in 4 billion freak, we should have to sift through billions of normal interstellar objects before stumbling upon it. Instead, it is one of the first such objects we have ever definitively detected. That is not how random sampling works. It's like walking into a casino for the first time, putting a single dollar into a slot machine and hitting the grand jackpot. Possible? Technically. Believable? Not at all. Let me give you another everyday comparison. The probability of being struck by lightning in your lifetime is about 1 in 15,000. The probability of winning a major lottery jackpot is about 1 in 300 million. The probability that 3i Atlas is a natural comet, 1 in 4 billion. You're roughly 300 times more likely to win the lottery than this object is to be a freak of nature. If someone told you they had won a major lottery 300 times in a row through pure luck, you would not believe them. You would assume the game was rigged, the system broken. Why then are we treating 3i Atlas differently? The honest answer is profound discomfort. The alternative explanation is psychologically and philosophically disquieting. It implies we are not alone. It implies a someone, or a something, with technology far beyond our own, sent an object through our solar system intentionally. It implies observation, it implies interest, It implies a cosmos that is not dead and empty, but potentially lively, watched and engineered. These are conclusions that carry enormous destabilizing weight. So we retreat. We retreat to natural explanations even when those explanations require stacking, coincidence upon coincidence until the mathematical foundation collapses into absurdity. We do this because the natural explanation, however wildly improbable, resides within a known framework. It feels safer, even if it requires believing in a near miracle. But science is not supposed to work on comfort. Science is supposed to follow the data wherever it leads, even when the path leads off the map into terrifying and unknown territory. The Copernican revolution was uncomfortable. It demoted Earth from the centre of creation to a mere speck orbiting an unremarkable star. The discovery of deep geological time was uncomfortable. It shrank human history to a brief flicker in eons of silent rock. The acceptance of biological evolution was uncomfortable. It removed humans from a pedestal of special creation and placed us squarely within the animal kingdom. Each time, the evidence forced us to abandon comforting central assumptions, and each time resisting the evidence only delayed progress and understanding. The question before us now is not whether accepting 3i Atlas as potentially artificial would be uncomfortable. Of course it would be. The question is whether the data supports it. And the math, the cold, hard, multiplicative math, screams that it does. Loeb emphasizes this is not about attaining metaphysical certainty. It is about assessing where the balance of probabilities lies given the current evidence. In the absence of any coherent natural model that explains the anomalies without invoking a chain of miracles, the artificial hypothesis is not fringe speculation. It is the statistically supported frontrunner. That doesn't mean it's definitely correct. It means that is where the arrow of probability points. And if NASA or any other major institution wants to maintain the official position that this is definitely a comet, they have a scientific obligation that goes beyond assertion. They need to provide physical mechanisms. They need to mathematically explain the columnation. They need to physically explain the dual pole symmetry. They need to dynamically explain the ecliptic alignment. To say it's a comet without engaging with and dismantling this probability stack is not science, it is denial. And that denial brings us to the institutional response, or lack thereof, which has been puzzlingly muted, verging on disinterested, given that we may be handling the most important discovery in human history. NASA's official position on 3i Atlas, paraphrased from a series of press statements, technical briefings and public comments by senior scientists, can be summarized succinctly. It is definitively a comet. An unusual comet certainly, perhaps one with anomalous outgassing behavior attributable to its formation in a different stellar environment with different chemistry or physics, but a comet nonetheless. The agency has not proposed any dedicated follow-up missions. It has not urgently redirected existing space-based assets like Hubble or the James Webb Space Telescope for intensive coordinated observation campaigns. It has not convened emergency panel reviews to scrutinize the possibility of a non-natural origin. The public message, both explicit and implicit, is that this object is not concerning enough to warrant extraordinary attention or resources. It is just another weird rock from interstellar space, and we will understand its quirks better someday, when we understand comets in general better. Before we go further, let's be clear about something critically important. This is not conspiracy theory territory. No one serious is suggesting that NASA is actively hiding evidence or deliberately suppressing a world-changing truth. What we are observing is a classic and well-documented phenomenon: institutional conservatism. Large, publicly funded scientific organizations, especially those operating in the high-stakes, high-visibility arena of space exploration, develop deeply ingrained cultures that favor continuity, caution, and incremental progress over disruptive, paradigm-shattering revelations. There are good, pragmatic reasons for this posture. False alarms damage public trust and scientific credibility. Premature announcements based on ambiguous data can create public panic or confusion. Overreacting to every anomaly wastes finite resources on dead ends. The instinct to wait for more data, to demand extraordinary evidence for extraordinary claims, is generally a healthy scientific safeguard. But conservatism transforms from a safeguard into a critical blind spot when it prevents an appropriate proportionate response to genuinely anomalous data. And by any objective measure, 3i Atlas is genuinely, profoundly anomalous. The beam geometry alone, a structure that violates basic gas dynamics, should have triggered immediate intensive follow-up using every instrument at our disposal. We should have commanded the James Webb Space Telescope to conduct deep infrared spectroscopy of the beam itself, analysing its molecular and ionic composition. We should have tasked the Hubble and every capable ground-based observatory to obtain the highest possible resolution images, searching for surface features, patterns, or evidence of non-natural geometry. If the orbital geometry allowed, we should have attempted radar observations with facilities like Goldstone or Arecibo, where it's still operational, to ping the object and determine its internal structure and rotation with precision. We should be throwing the full weight of our astrophysical toolkit at 3i Atlas while it is still within observational range, because it is on a one-way trip out of the solar system. With every passing day, it grows fainter, and the opportunity to gather definitive data slips through our fingers. Instead, the institutional response has been characterized by relative routine, cataloguing the object, conducting standard analysis on existing survey data, publishing papers that note the discrepancies, but ultimately file them under interesting future work. This is not the response profile for an object that might represent first contact with extraterrestrial technology. It is the response profile for a moderately interesting comet. The standard go-to explanation offered to diffuse the anomalies is the birth environment hypothesis. The argument is that 3i Atlas formed around a different star in a protoplanetary disk with chemical compositions, temperature gradients, or dynamical conditions radically different from those in our own solar system. These unique formation circumstances, the argument goes, could theoretically produce a comet with unusual bulk properties, strange composition, unusual density, or exotic internal structure. This might explain why its spectra look a bit off, or why its outgassing seems odd. It's the astronomical equivalent of saying, it's from out of town. Here is the fatal flaw in that argument. Formation environment might explain intrinsic properties, but it cannot explain active, responsive geometry specific to our solar system. The beam does not point in some random direction determined billions of years ago during the object's formation. It points at our sun. It activates precisely when the pole from which it emits is facing our sun. Both poles do this. The object's trajectory is aligned with our ecliptic plane. These are not properties encoded during formation in a distant star system. They are behaviors enacted in response to the specific, local conditions of our solar system right now. Formation history does not, cannot, pre-program an object to emit perfectly columnated beams towards stars it will encounter millions of years in the future. That's not physics, that's prescience. If 3i Atlas has unusual intrinsic properties from a weird stellar neighborhood, those properties would be passive and constant. A weird ratio of nickel to iron is passive, an unusual spin rate is passive, but producing emissions that are actively oriented toward a star you are currently passing requires sensing the local environment and responding to it. It requires an active feedback loop, sense star, aim beam. That is not a formation property, it is active behavior. An active, goal-directed behavior implies control systems. It implies technology. You cannot hand-wave that away by vaguely invoking a different birthplace. The birth environment hypothesis is not a solution, it is a diversion, a way to avoid the uncomfortable question by appealing to an unknown elsewhere. There is also a critical concept in decision theory and science called risk asymmetry. In any investigation, you must balance two types of errors. A type 1 error is a false positive, claiming something is true or significant when it is not. A type 2 error is a false negative, failing to recognize something true or significant because you demanded too much evidence. In most everyday science, we are heavily biased toward avoiding type 1 errors. False alarms are embarrassing, they waste grant money, and they can damage careers. Caution is the prudent path. However, when the potential stakes are astronomically high, the calculus of risk must change. Missing a true positive, a type 2 error, can become the far greater failure. Apply this to 3i Atlas, scenario A. The object is just a weird comet, but we treat it as potentially artificial and launch a massive urgent investigation. The cost? We spend some telescope time, allocate some research funding, and perhaps face some embarrassment if it turns out to be natural. We learn a tremendous amount about interstellar objects in the process. Scenario B. The object is an artificial probe, but we dismiss it as just a weird comet because we demand impossible levels of certainty up front. The cost? We miss the single most important discovery in the history of science, the proof that we are not alone, that the galaxy is filled with intelligence. We remain in ignorant isolation. The asymmetry is stark. The potential downside of investigation is minor and temporary. The potential downside of dismissal is catastrophic and permanent. Rational risk management, when the potential payoff is universe-altering, says you investigate aggressively. Yet the institutional stance seems rooted in the opposite assumption. It is definitely not artificial unless proven otherwise beyond any conceivable doubt. That is backwards. It is allowing the fear of a modest Type 1 error, embarrassment, to blind us to the risk of an existential Type 2 error, cosmic ignorance. History is littered with instructive examples of this dynamic, where institutional conservatism delayed paradigm shifts for decades. Continental drift was proposed by Alfred Wegener in 1912, supported by clear geological and fossil evidence, and was ridiculed by the geological establishment for half a century, until plate tectonics provided the mechanism and forced acceptance. The French Academy of Sciences in the late 18th century famously dismissed reports of rocks falling from the sky, meteorites, as peasant superstition, because rocks do not fall from the sky. Fossilized dinosaur footprints were explained away as natural erosion or carvings by ancient peoples because the concept of extinct giant reptiles was philosophically troubling. In each case, the evidence was available long before the scientific community accepted it. Acceptance required overcoming not just a lack of data, but institutional inertia, professional reputations, and deep-seated conceptual comfort. We are potentially watching the same script play out in real time with 3i Atlas. The pressing question is this: what would actually trigger a reassessment? What specific observation would move NASA from definitely a comet to we need to seriously consider alternatives? Because right now, with 15 distinct anomalies, with probability calculations in the 1 in billions, with beam geometries that violate textbook physics, the bar for reconsideration seems impossibly, almost deliberately, high. If the answer is that no observation short of the object transmitting a welcome message in English would ever trigger a reassessment, if the artificial hypothesis is ruled out a priori as impossible, then we are no longer engaged in science. We are engaged in dogma. We are protecting a worldview rather than following evidence. Maybe that worldview is ultimately correct. Maybe there is exotic comet physics waiting to be discovered that explains everything. Maybe Avi Loeb's calculations are missing a crucial unifying factor. But until someone actually provides those mechanisms, publishes the math, and shows how they work without invoking a chain of miracles, the natural explanation remains a placeholder, a wish, a piece of hand-waving. It is an appeal to future knowledge we do not currently possess. It is saying, trust us, there must be a natural explanation, because the alternative is too strange to contemplate. That is not scientific reasoning. That is motivated reasoning. And the fact that it emanates from prestigious authoritative institutions does not make it more valid. It only makes it more influential, and more dangerous if it is wrong. The beam is still there in the data. The symmetry is still there in the geometry. The probability is still 1 in 4 billion. NASA's official position does not change these facts. It only postpones the necessary urgent conversation. Because if the natural explanation genuinely does not work, and so far it has not, then we are left with something else, something that fits the data better, something we have been avoiding because accepting it would change everything we thought we knew about our place in the universe. And that is where we must go next, into the territory of what else actually fits, into the models nobody in the mainstream wants to discuss, but towards which the data keeps relentlessly pointing. When confronted with the sheer impossibility of the beam, the scientific community has scrambled to propose natural mechanisms that could, in theory, produce such a phenomenon. One of the more creative and persistent ideas is what I call the gun barrel hypothesis. The concept is deceptively simple. Perhaps 3i Atlas possesses deep, narrow shafts or cavernous tunnels extending straight down into its interior. If solar radiation could somehow penetrate and heat volatile ices at the bottom of these shafts, then the walls of the shaft itself would act as a natural nozzle, channeling and columnating the erupting gas as it escapes into space, much like the barrel of a rifle guides a bullet. It's a clever mental image, an attempt to solve the columnation problem using nothing more than natural geology. and it falls apart completely under even mild scrutiny, collapsing into a pile of additional impossibilities the moment you think about it for more than a few minutes. First, consider the genesis of such a cavity. Comets are not precision-machined objects. They are the leftover debris from planetary formation, aggregates of ice, rock, and dust that clump together under weak gravity in the frigid outskirts of a protoplanetary disk. Their formation process is stochastic, chaotic, and messy. You get irregular shapes, rubble pile structures, and random voids from uneven accumulation. You do not get perfectly straight, deep, vertical shafts with smooth, parallel walls. Natural geological processes on comets, like sublimation-driven erosion or gas pressure blowouts, can create pits, caves, and even tunnels, but these features are irregular, branching, tortuous, and structurally unstable. They widen, collapse, and change shape rapidly as the comet loses mass. A perfectly straight shaft, hundreds of meters deep with walls smooth enough to collimate gas flow over planetary distances, is not geology. It is engineering. But let's grant the first miracle. Somehow, through a sequence of events so unlikely it beggars belief, 3I Atlas formed with one such precision gun barrel cavity at its north pole. Now you immediately need a second miracle, an identical cavity at the south pole. Not a similar pit, but an identical one. Same depth, same diameter, same wall smoothness, same orientation relative to the surface. Because, as we've established, both poles produce beams with matching columnation characteristics. The chances of one such shaft forming naturally are astronomically small. The chances of two forming with mirror geometry is that already tiny probability squared. We are back to multiplying impossibilities. Then there's the unavoidable problem of erosion, a problem that's fatal to the model. Comets near a star are engines of their own destruction. They sublime constantly. Any active vent or channel is subject to intense thermal and mechanical erosion. The walls of a narrow shaft directing a high-velocity gas jet would be directly exposed to that flow. The hot gas would sublime the icy walls, widening the channel rapidly. We have observed this directly on solar system comets. Jets evolve. Their source vents enlarge and morph, sometimes in a matter of days. A gun barrel cavity would be a suicide mechanism. The very process it is meant to channel would destroy its perfect geometry. The feature might produce a columnated flow for a few hours, before thermal erosion destroyed the precise wall alignment, turning it into a widening, ragged hole. It could not sustain a stable beam for 6 days. The beam we saw was stable, its geometry was constant. This implies a source that is not eroding, or is actively maintaining its shape against erosion, another hallmark of a controlled system, not a passive geological feature. A further complication is rotation, a factor often glossed over in this hypothesis. 3I Atlas is tumbling. It is not tidally locked to face the sun with one pole. Its rotation period is several hours. This means that a fixed shaft at one pole is only pointed directly at the sun for a brief window during each rotation. For the rest of the spin cycle, the shaft is angled away. Solar heating would thus be intermittent, and more critically, the geometric alignment for channeling a sunward beam would be lost for most of the time. You would expect to see a pulsed, episodic beam, flashing on only when the shaft aligns, then vanishing as it rotates away. Instead, we observe a continuous, unwavering beam over days. This requires one of two things. Either the shaft is somehow constantly reoriented to face the sun, which implies an active aiming mechanism, or the emission mechanism itself compensates for the rotation, firing only when aligned in a precisely timed sequence, which implies a control system. A passive fixed shaft in a tumbling body cannot explain a continuous beam. Let's be explicit about what's happening here with this and other natural explanations. We start with a conclusion. It must be natural. We then take an observation that violently contradicts natural behaviour, the columnated beam, and invent a highly specific, wildly improbable natural structure, the gun barrel, to explain it. When that structure immediately creates new problems, erosion, the need for a twin, rotation, we invent additional improbable conditions to solve those problems. Maybe the walls are made of super-refractory material. Maybe the spin axis is perfectly aligned. Maybe both shafts formed simultaneously from a single impact. We are not removing improbabilities, we are piling them on. Each new requirement is itself implausible. Together they construct a towering edifice of coincidence that becomes more extraordinary than the single, simple assumption we're trying to avoid. that the object was designed. This cognitive process is eerily reminiscent of the epicycles of pre-Copernican astronomy. When you are dogmatically committed to the idea that Earth is the center of the universe, and you observe the planets moving in complex loops, retrograde motion, you don't abandon your core belief. You add circles upon circles, epicycles and deference to the planetary orbits to mathematically account for the weird motion. The math can be made to work, but the model becomes grotesquely complex and physically nonsensical. The far simpler, more elegant explanation, that the planets orbit the Sun, was rejected because it challenged the foundational worldview. The gun barrel hypothesis, and others like it, are the epicycles of the 3i Atlas debate. You can construct them if you have enough faith and are willing to ignore compounding improbability. Or you can consider the simpler, more parsimonious idea. Maybe it was built. The gun barrel hypothesis reveals a profound cognitive bias in our approach to cosmic anomalies. We are so deeply committed to a universe devoid of other intelligence that we will accept incredible complexity, layers of unlikely coincidence, and violations of Occam's razor rather than entertain the possibility of design. This is not unique to astronomy. It is a pattern throughout history whenever data challenges a deep-seated paradigm. The human mind is an excellent pattern recognition machine, but it is also a powerful pattern rejection machine when the recognized pattern implies something psychologically uncomfortable, and nothing is more uncomfortable than evidence suggesting we are not the only sentient occupants of the cosmos. But let's press on. Suppose you reject the gun barrel model as too contrived. There is one other natural mechanism that has been proposed, and it is arguably the strongest counterargument to the artificial hypothesis. It's called rotational stabilization, or the rifle bullet model. The physics here is solid and worth taking seriously. The idea is that if the object is spinning rapidly around its long axis, like a bullet fired from a rifled gun barrel, then any jet or emission aligned with that spin axis will maintain a fixed direction in space due to gyroscopic stability. The rotation provides a kind of inertial guidance, keeping the emission geometry locked even as the object moves along its trajectory. This is real, testable physics. It works. And it explains exactly one thing while ignoring a dozen others. The rifle bullet hypothesis could absolutely explain why a jet from one pole maintains a consistent direction. If 3i Atlas is spinning fast enough, and if by chance there is an active vent located exactly at one of the rotational poles, then the emission from that vent would be rotationally stabilized. You would get a persistent directed jet. Great. Solved. Now, explain the second jet. Explain why both poles, which are opposite ends of the rotation axis, both possess active vents. Rotational stabilization doesn't create vents. It only stabilizes whatever vent happens to exist. It doesn't cause them to appear, and it certainly doesn't coordinate their properties. So we are right back at the symmetry problem. We need two vents, located at precisely opposite poles. We need both vents to have the same opening geometry, the same gas pressure and composition, the same subsurface reservoir conditions. We need the internal structure of the object to be perfectly symmetric across the rotational equator, despite the object presumably forming through the random, chaotic process of accretion. And we need all of this to be true for an object that is already anomalous in 14 other independent ways. The rifle bullet hypothesis solves the directional stability problem, but makes the coincidence problem infinitely worse. It explains how a beam could stay pointed, but not why there are two identical beams. This is the core failure of all natural models attempted so far. They are piecemeal. They can address individual anomalies in isolation by invoking a new, specific mechanism for each one. But they cannot address the coordinated pattern. They cannot explain why every single strange feature converges on one object. It's like finding a house in the woods where every door is exactly 2.13 meters tall, every window is an equilateral triangle, and every roof tile is made of polished obsidian. You could, I suppose, propose that trees naturally grow to 2.13 meters, that lightning fractures rocks into perfect triangles, and that volcanic glass naturally forms in tile-like sheets. Technically, each statement has a sliver of physical possibility, but the conjunction of all of them in one functional structure is absurdly unlikely. The far simpler explanation is that someone built the house with a consistent design language. We resist that explanation when the house is orbiting the sun because accepting it forces us to accept implications we are culturally and psychologically unprepared to face. Yet consider this. If you asked a systems engineer to design a long-duration interstellar probe that needed to orient itself relative to a star and emit directional radiation, whether for propulsion, communication, or shielding, what would they create? They would likely build in redundancy. They would place emission ports at opposite ends of the structure. Why? Because if one system fails or if the probe is tumbling, you ensure that at least one port can be brought to bear on the target. You ensure full sky coverage. You use the object's geometry to guarantee functionality regardless of orientation. Two symmetrically placed systems are a hallmark of robust, fault-tolerant design. In nature, you don't get such functional symmetry without selective pressure, without evolution. But 3i Atlas isn't alive. It hasn't evolved. If its symmetry is functional, if it serves the clear purpose of ensuring a sunward beam regardless of orientation, then that function almost certainly came from a designer's intention. And that is the quiet, logical conclusion we keep circling back to from every angle of analysis. Let's give the rifle bullet hypothesis its due respect. It is the best, most physically grounded natural explanation currently on the table, and it deserves a thorough and fair examination. The underlying physics is impeccable. When any object rotates rapidly around its principal axis, that spin creates gyroscopic stability. Angular momentum is conserved, and the axis of rotation will tend to point in a fixed direction in inertial space, resisting external torques. This is precisely why a rifle bullet, spun by the rifling in the barrel, remains nose forward in flight, achieving a stable trajectory. If 3i Atlas is spinning sufficiently fast, and if its rotational poles are aligned in a fortuitous way, and if there are active vents at those poles, then the emissions from those vents would indeed be shot out along the spin axis, maintaining a constant direction. Observations of the object's light curve, the periodic brightening and dimming as it tumbers, strongly suggest it is rotating, with a period estimated at several hours. That's not exceptionally fast for a small body, but it is enough to provide some gyroscopic stiffness. If the rotation axis happens to be oriented such that it points roughly toward the Sun during specific phases of the orbit, and if vents exist at the poles, you could theoretically get sustained sunward-directed emissions. The geometry can be made to work on paper. The physics is sound. This explanation doesn't require inventing exotic new states of matter or impossible geology. It uses well-understood classical mechanics to explain an observed phenomenon. That is good science. We should always prefer explanations rooted in known physics. However, here lies the critical, fatal distinction. Rotational stabilization is a mechanical effect. It is not a generative cause. It stabilizes whatever emission geometry already exists. It does not create that geometry, dictate its location, or coordinate its properties. So while the rifle bullet hypothesis can elegantly explain why emissions from the poles might maintain a consistent direction in space, it cannot explain why both poles have emissions in the first place. And it absolutely cannot explain why those emissions are identical in their most baffling characteristics: their columnation angle, their persistence, their intensity profile. Rotational stabilization is a necessary component of a complete explanation, but it is wildly insufficient by itself. Think carefully about the full observational record. Before perihelion, the North Pole produces a columnated beam. After perihelion, the South Pole produces a columnated beam. Both beams have the same angular width, 6 to 8 degrees. Both maintain columnation across the same astronomical distance, 500,000 Hilonkelm. Both are oriented precisely sunward. Both persist for multiple days without flickering or wandering. The rifle bullet model says, fine, both poles are aligned with the rotation axis, so emissions from them are stabilized. That's why they don't waver. But that statement simply assumes the existence of the two polar vents. It does not address the profound questions. Why are there two? Why are they identical? Why do they activate in perfect sequence, one taking over precisely as the other falls silent, in lockstep with which pole is sunward? Rotation provides no answer to these questions. It merely takes the vent's existence and perfect symmetry as given, as a miraculous starting condition. In planetary geology, when you see symmetry, you instinctively look for a process that would create it. Tidal forces can create symmetry, like the tidal locking of a moon. Centrifugal forces from rotation create equatorial bulges. Large-scale magnetic fields can create symmetric structures like radiation belts. But pole-to-pole symmetry and surface features, especially features as specific as active precision emission vents, is not something rotation generates. Rotation preserves the orientation of pre-existing features aligned with the axis. It does not dictate that such features must exist, nor that they must be twins. If 3i Atlas had two active vents at opposite poles purely by random chance, that is already a low probability event. If those vents happen to produce emissions with identical, highly anomalous columnation, that is an exponentially lower probability event. If those emissions happen to activate in perfect alternation, coordinated with solar aspect, we are stacking improbabilities yet again. The causality is essential here. Rotational stabilization is an effect, not a cause. It stabilizes features that already exist, but it provides zero explanation for why those features have the specific, improbable properties they do. To use an analogy, if I observe two factories on opposite hills, each producing an identical peculiar plume of green smoke, and both plumes are blowing in the same direction because of a steady wind, I can invoke the wind to explain the common direction of the plumes. But the wind does not explain why the two factories exist, why they are symmetrically placed, why they are both operating, or why they are both producing the same unique green smoke. The rifle bullet hypothesis is explaining the wind direction, when the real, monumental mystery is the factories themselves. There's also a subtle but serious issue with timing and orientation that the rifle bullet model glosses over. For the North Pole to emit sunward before perihelion, the rotation axis needs to be oriented in one specific way relative to the Sun. For the South Pole to take over and emit sunward after perihelion, either the rotation axis must have flipped 180 degrees, or the object's trajectory must have changed its solar aspect in a very specific manner. Rotational axes in space are not fickle. They are conserved unless acted upon by a substantial external torque. The gravitational forces during perihelion passage are symmetric and would not cause a major reorientation of the spin axis. So we are left needing another coincidence. Either the object's initial spin axis orientation was perfectly fortuitous to enable this pole switching behavior, or some unobserved torque, perhaps from asymmetric outgassing, perfectly reoriented it at just the right moment. More stacked miracles. Let me be unequivocal. No one is arguing that rotational stabilization isn't occurring. It almost certainly is. The object is spinning, and that spin undoubtedly influences the emission geometry. What is being challenged is the deceptive presentation of this one mechanism as a comprehensive explanation. It is not. At best, it's one piece of a much larger unsolved puzzle. It's a mechanism that makes the observed directional persistence less impossible than if the object were not spinning, but it does not make the overall phenomenon probable. It doesn't explain the pattern. Presenting rotational stabilization as a sufficient answer is, at best, intellectually incomplete, and at worst, intellectually dishonest. The broader pattern evident in all these natural explanations is their inherent need for additional unexplained symmetries. The gun barrel hypothesis requires identical cavities at both poles. The rifle bullet hypothesis requires identical vents at both poles. Every model ends up needing the same thing: perfect mirroring between opposite ends of the object. And natural processes, especially those involved in the formation of small primitive bodies, do not generate that kind of precise functional symmetry without a clear, ongoing physical cause. Tidal locking creates symmetry through a continuous, overwhelming force. Crystal growth creates symmetry through repeating molecular patterns. But there's no continuous force here sculpting both poles simultaneously. There's no repeating molecular pattern at a 500,000 kilometer scale. 3i Atlas is a singular object with singular coordinated geometry. If that geometry is both symmetrical and functional, serving the clear purpose of maintained sunward emission, then the most straightforward inference, the one that requires the fewest independent assumptions, is that it was designed to be that way. An engineer would recognize this immediately. Bilateral symmetry in a system with a directional function is a hallmark of intentional design. Airplanes have symmetrical wings because asymmetry causes catastrophic instability. Ships have symmetrical hulls for stable tracking in water. If you stumbled upon a perfectly smooth metallic sphere in the middle of a forest, you would not assume it was formed by natural erosion. You would assume it was manufactured, because spheres of that perfection do not emerge from chaotic natural processes without a specific sustained shaping mechanism. 3i Atlas presents us with bilateral functional symmetry. That is a design hallmark. But wait, a counter-argument arises. Could this be a natural selection effect? What if only interstellar objects with this kind of symmetry survive the long journey between stars and we're only seeing the survivors? This is a fair question, but it rests on two unsupported premises. First, it requires a vast population of interstellar objects upon which selection can act. Our sample size is still tiny. Second, and more decisively, it requires a selection pressure that favours symmetry during interstellar transit. Interstellar space is almost perfectly empty. There is no friction, no wind, no fluid medium that would aerodynamically select for symmetrical shapes. An irregular rock and a perfect sphere will coast just as easily. Unless you're proposing that symmetrical objects are more likely to be artificial, and therefore more likely to be sent on intentional voyages, in which case you've inadvertently argued for the artificial hypothesis. The fatal flaw in the rifle bullet hypothesis, and indeed in all natural models proposed to date, is that they explain possible mechanisms while ignoring overwhelming probability. Yes, rotational stabilization can explain directional persistence. Yes, gun barrel cavities could theoretically columnate gas. Yes, an unusual birth environment might explain strange chemistry. All these mechanisms are physically possible in isolation. But they are not all compatible with each other on one object, without invoking a chain of independent low-probability events. Each mechanism requires its own set of unlikely initial conditions, and collectively they require so many coincidences that the compound probability plunges into the realm of the absurd. At some point, invoking 10 different unlikely natural mechanisms, each solving one piece of the puzzle, becomes less parsimonious, less simple, than invoking one single instance of technology. That point, for anyone rigorously applying Occam's razor, was likely past several anomalies ago. The data for 3i Atlas doesn't just suggest something unusual, it presents a coherent functional pattern that natural chance struggles to replicate even in theory and fails to replicate in probability by a factor of billions. If we entertain, even as a thought experiment, the possibility that 3i Atlas is artificial, the immediate and vital question becomes, what is its function? What purpose do these precise sunward beams serve? Here we must tread with extreme care, separating solid observation from speculative interpretation. The beams exist. Their columnated geometry exists. Their dual pole symmetry exists. Their sunward orientation and precise activation timing exist. These are empirical facts, etched into the data from multiple observatories. Everything beyond this, the why, is necessarily hypothesis. But a hypothesis grounded in known physics and logical inference is still valuable. It helps us distinguish between technological explanations that are merely fanciful and those that could plausibly fit the evidence. So let's think this through systematically, ruling out what doesn't fit before considering what might. First, we can rule out propulsion. It's the most obvious guess. Maybe the beams are thrusters. But the timing is all wrong. The most powerful beams were observed post-perihelion as the object was already on its outbound hyperbolic trajectory, having reached its maximum solar velocity. If you were using stellar energy for propulsion, you would activate your main drive before perihelion to accelerate toward the star, using its gravity to slingshot you even faster. You wouldn't wait until you were already flying away. Furthermore, the beams point at the sun. For thrust, you expel reaction mass opposite to your desired direction of travel. A sunward beam would, if anything, push the object away from the sun, a braking maneuver as it departed. But the object's trajectory shows no detectable, non-gravitational accelerations consistent with such a braking thrust. Its path is ballistic, shaped purely by gravity. Propulsion doesn't fit. Second, we can confidently rule out weaponry. The idea of a weapon aimed at the sun is scientifically nonsensical. The sun is a gargantuan fusion reactor, outputting about 4x 10^26 watts of power. Any beam a comet-sized object could generate would be less than a mosquito's bite in comparison, having zero measurable effect. There is no tactical or strategic logic to firing at a star from within its own system, and no evidence of any target or effect. Invoking weapons requires constructing an entire narrative of interstellar conflict from whole cloth. That's storytelling, not science. Third, communication is more plausible but still strained. If you wanted to communicate with something near the sun, or using the sun as a gravitational lens, a theoretical concept, you might use a directed beam. But communication beams are modulated. They carry information. You would expect to see pulses, frequency shifts, or intensity variations encoding data. The beam from 3i Atlas, in all our observations, appears steady state. It's constant in intensity and structure. It doesn't pulse or vary in a way suggestive of signal encoding, it's just on. While not definitive, the lack of obvious modulation makes a pure communication function less likely. So, what function remains? What requires a sustained, directed emission toward a star without the need for thrust, modulated data, or destructive power? The answer that best fits the physics, the geometry, and the context is shielding, specifically active plasma or particle shielding against stellar radiation. This is where speculation connects to real ongoing human research, and it becomes profoundly interesting. Interstellar space is not benign. It is filled with a lethal radiation. The solar wind, a stream of charged particles, cosmic rays, high-energy particles from across the galaxy, and intense ultraviolet and X-ray flux from the star itself. When you approach a star closely, this radiation environment intensifies dramatically. For any delicate system, whether biological or sophisticated electronics, this is a severe hazard. On human spacecraft, we use passive shielding, thick layers of water, polyethylene, or metal to absorb radiation. But mass is the enemy of interstellar travel. Hauling tons of shielding makes acceleration fantastically difficult. There is therefore a powerful engineering incentive to develop active shielding, using electromagnetic fields or emitted plasma to deflect charged particles, creating a protective bubble. Earth has a natural version. Its magnetosphere deflects the solar wind. NASA and other space agencies are actively researching artificial magnetospheres for spacecraft to protect astronauts on Mars missions. The concept is to generate a magnetic field strong enough to channel harmful particles around the hull. Now, envision an interstellar probe designed for longevity, sent to explore unknown star systems. It doesn't know the radiation environment it will encounter. A fixed magnetic field might be insufficient or poorly oriented. A more robust, adaptable solution might be to actively emit a stream of charged particles or plasma sunward. This emitted material would interact with the incoming stellar wind, creating a bow shock, a protective interaction region, ahead of the probe. The emitted particles act as a buffer, deflecting and scattering the more dangerous incoming radiation. This explains the sunward orientation perfectly. You emit toward the source of the hazard. It explains the persistence. You need shielding continuously while in the high radiation zone near a star, not just in bursts. It explains the scale. A bow shock needs to form at a distance sufficient to protect the craft. 500,000 kilometers is a plausible standoff distance for such an interaction with the solar wind. It elegantly explains the dual-pole geometry. If your probe is tumbling, or you cannot guarantee which end will face the star upon arrival, you build redundant systems at both poles. When the North Pole faces the Sun, it activates. As rotation brings the South Pole to bear, it takes over. This is fault-tolerant, robust engineering for an autonomous system operating over millennia. Redundancy and symmetry aren't puzzling in this model. They're essential, intelligent design features. Of course, the technology required to generate a directed plasma beam intense enough to create a protective bubble at 500,000 kilometers is far, far beyond our current capabilities. It would require energy sources and control systems we can barely imagine. But the physics is not magic. It doesn't violate any laws of nature. It is merely an extreme application of known principles. To a human from the Bronze Age, a jet engine would seem like impossible magic, but it operates on principles of combustion and thrust that were always true. The gap between our technology and what 3i Atlas might represent is one of degree, not kind. The shielding hypothesis has a significant advantage. It explains function without requiring us to guess at alien motives or messages. It assumes only that the builders of such a probe face the same universal physics we do, and that they wish their creation to survive the harsh environment of a stellar flyby. That is a minimal, reasonable assumption. It doesn't require tales of communication or warfare. It simply requires a desire for the probe's continued operation, a premise foundational to any engineering project. This is all, admittedly, speculative. We have no spectral data confirming the beam is composed of plasma. We cannot measure its magnetic properties. But what we have is a pattern of observations that natural models fail to explain, yet which align neatly with a specific, logical, technological function. The artificial hypothesis in this form isn't just compatible with the data, it becomes explanatory in a way the natural hypothesis is not. It connects the dots. The sunward aim, the persistence, the dual pole redundancy, the timing, into a coherent, functional whole. It makes predictions. If we could analyse the beam, we might find it consists of ionised particles rather than neutral gas. It might be accompanied by a local magnetic field. The object's surface might show evidence of non-eroding manufactured apertures. A good scientific hypothesis should do exactly this: provide a framework that explains existing anomalies and offers testable predictions. The natural comet hypothesis currently does neither. It merely asserts a category and waves away the contradictions. The shielding hypothesis, while bold, provides a narrative that fits, and it forces us to consider the next, even more daunting question. If the behaviour is technological, what about the structure itself? What is this thing made of? The answers, as we've glimpsed, are just as unsettling. Early spectroscopic analysis of 3I Atlas, conducted during its brightest approach using the world's most powerful ground-based telescopes, detected a tantalising and controversial hint in the faint emission lines, an apparent anomaly in nickel. Specifically, some analyses suggested an elevated ratio of nickel to iron compared to what is typical for solar system comets or primitive bodies. Before we dive into the implications, a massive caveat is essential. This data is borderline. Spectroscopy of a faint distant object is an exercise in pulling signal from noise. The data is sparse, the lines are weak, and different research groups using different processing techniques have reached differing conclusions. Some see a clear nickel signature, others see only noise. Some argue the possible enhancement is within error margins. This is not a smoking gun. It is a faint, ambiguous whisper wrapped in layers of uncertainty. But in a mystery of this magnitude, even whispers deserve our attention. So let's explore why elevated nickel-to-iron ratios would be significant if confirmed, and why this ties into the broader pattern of anomalies. Comets are primitive, undifferentiated relics. They are aggregates of the original dust and ice from a protoplanetary disk, never heated enough to melt and separate into core, mantle, and crust. Their composition should therefore reflect the average bulk chemistry of their birthplace. For Sun-like stars, that means certain elemental ratios are fairly consistent. Iron is relatively abundant. Nickel is present, but typically less so, with Fe ratios around 16:1 to 21 in most primitive solar system materials. If 3I Atlas shows a ratio skewed toward more nickel, a lower Fe ratio, it is compositionally weird. Now, why would that matter for the artificial hypothesis? Because nickel-iron alloys are not just geologically interesting, they are industrially vital. Nickel added to iron creates alloys, like stainless steel or Invar, with highly desirable properties: corrosion resistance, strength across wide temperature ranges, low thermal expansion. These are precisely the properties you would want for a long-duration interstellar probe. A hull or structure that can withstand thermal cycling, cosmic ray bombardment, and molecular erosion over millions of years. An enrichment in nickel, relative to cosmic background, could be interpreted as a signature of material selection for engineering purposes, not just random accretion. Of course, elevated nickel can occur naturally. It is found in certain types of differentiated meteorites, particularly iron meteorites that are fragments of asteroid cores. In a large body that melted, heavier elements like nickel and iron sank to the core, and the exact ratio can vary based on formation conditions. So if 3I Atlas were a fragment of a shattered planetesimal core, it could have unusual metal ratios. But here's the catch. That would mean it is not a comet. Comets, by definition, are undifferentiated. A differentiated metallic fragment is a different class of object entirely, one that underwent significant thermal processing and planetary scale geology. So the nickel hint forces a choice. If it's real, either 3I Atlas is a weird comet with inexplicable metal ratios, or it's a non-comet, a metallic fragment, that is somehow producing massive columnated gas jets, which is even more physically bizarre. Either way, the composition adds another layer of wrongness to the story. The spectroscopic data is further complicated because we are not measuring the solid body directly. We are measuring emission lines from atoms and ions in the gaseous coma, material that has been sublimated or otherwise ejected from the surface. Different elements vaporize at different rates, depending on their chemical bonding and the local temperature. The ratio in the gas might not perfectly mirror the ratio in the solid. This fractionation adds another layer of uncertainty. Multiple teams have wrestled with this inverse problem, and consensus remains elusive. Some argue the signal is just too noisy. This frustration highlights one of the great tragedies of the 3i Atlas story, the lack of decisive follow-up. With dedicated observation time on space-based infrared spectrometers, we could have resolved these questions. We could have measured isotopic ratios, like iron 60 or nickel 60, that are telltale signs of formation environment, or even artificial processing. We could have searched for organic compounds or other diagnostic materials. But that intensive effort was never prioritized. 3i Atlas is now too distant, too cold, and too faint. The window for high-quality compositional data is closed, leaving us with arguments over marginal signals in noisy datasets. This is a failure of scientific risk assessment, a failure to recognize the potential stakes. Beyond nickel, there's the curious case of what we didn't see: dust. Comets are notoriously dusty. Sublimating ice carries embedded dust grains into space, creating the bright, reflective coma and the sweeping dust tails. 3i Atlas showed gas emissions orders of magnitude more structured than any comet, but its dust production was curiously low relative to the gas. The dust-to-gas ratio was anomalously small. This is consistent with an object whose solid component is not a loose aggregate of ice and dirt, but something more cohesive, less prone to shedding particulates. A metallic or composite manufactured hull would fit that description perfectly. Again, it's not proof, but it's another point of consistency with the artificial hypothesis. The compositional story, fragmentary though it is, adds weight to the overall pattern. It suggests that the anomalies are not merely behavioral, they might be structural. We might be looking at an object that not only acts like a machine but is built like one. The materials, the symmetry, the function, they begin to sketch the contours of a designed artifact. But the most compelling pattern, the one that truly hints at intent, isn't found in any single measurement of composition or behavior. It's found in the relationship between 3i Atlas and our solar system itself. It's the pattern of specific targeted adaptation to our local environment, and that is where the evidence for design becomes almost impossible to avoid. Ask yourself a simple question. If you were a random interstellar object, a piece of debris ejected from some distant star system millions of years ago, what are the odds that your trajectory would arrive in our solar system perfectly aligned with our ecliptic plane? The ecliptic is the flat disk in which our planets orbit. It's a specific geometric plane, a two-dimensional slice in a three-dimensional galaxy. Interstellar space has no preference for this plane. Objects should approach from all angles with equal probability. The chance that a random trajectory lies within a narrow band of, say, 2 degrees of our ecliptic is roughly 1 in 100. 3i Atlas didn't just graze this plane. Its entire hyperbolic orbit is coplanar with our solar system to within an astonishing precision. It came in along the ecliptic, passed through perihelion, and is leaving along the ecliptic. This is not a random trajectory. This is the trajectory you would choose if you were designing a probe to conduct a flyby survey of a planetary system. It maximizes the time spent in the plane, where all the interesting stuff is. The planets, the asteroids, the densest part of the solar wind and radiation environment. A random rock doesn't care about this optimization. A probe sent to gather data would care very much. This ecliptic alignment is the first pillar of a deeper, more disturbing pattern. 3i Atlas seems peculiarly, specifically configured for interaction with our solar system. Consider the beams again. They don't point in a fixed direction in space, locked to the object's formation history. They point at our sun. They activate precisely when the respective pole is facing our sun. This is active, real-time orientation to our local star. Natural cometary emissions are driven by heat, but their direction is dictated by local vent geometry and rotation. They are not aimed with stellar precision. The beams of 3i Atlas are aimed. This requires either a sensor tracking the sun or a mechanical configuration that inherently aligns with the solar direction. Neither is a property of natural interstellar debris. Now layer in the timing. 3i Atlas was discovered inbound in late 2023. It reached perihelion in January 2025. Its most dramatic anomalous beams appeared post-perihelion as it was departing. This activation profile makes perfect sense for a system conserving energy. On approach, passive observation and minimal systems suffice. At perihelion, the radiation environment is most extreme, requiring maximum shielding. Post-perihelion, as it leaves, continued shielding protects it during departure. If the beams are an active shield, this activate when needed profile is logical for a probe with finite energy reserves. You don't run your highest power systems continuously over million-year journeys. You turn them on when the environmental threat demands it. The dual-pole redundancy makes equally perfect sense from an engineering perspective. You cannot control the tumble state of a probe after an interstellar journey. By placing identical emission systems at both poles, you guarantee that one will always be roughly sunward, regardless of orientation. This is not a natural symmetry. It is a design solution for a known problem of deep space navigation and reliability. Even the trajectory's kinematic parameters are suggestive. 3i Atlas is on a hyperbolic orbit, meaning it is not bound to the Sun. Its hyperbolic excess velocity, its speed relative to the Sun at infinite distance, is about 30 km/s. This is fast enough to ensure it won't be captured, but slow enough that it spent a considerable amount of time in the inner solar system. It's a Goldilocks trajectory. Not so fast it zooms through unnoticed, not so slow it gets stuck. It allowed for an extended period of observation or shielding operation near the Sun. Furthermore, its path shows no signs of gravitational perturbation from planets. It didn't have a close encounter with Jupiter or Earth that altered its course. It came in on a clean, clear hyperbolic arc, passed through the inner system, and is leaving on a clean, clear hyperbolic arc. This is exactly what you would expect from a probe on a planned flyby, not from a piece of debris that might be randomly deflected by planetary encounters. Then there is the meta-pattern of detectability. 3i Atlas was discovered by our Pan-STARRS survey telescope. It was bright enough and close enough to be found. But interstellar space is vast, and our detection capabilities are still limited. We only see objects that come relatively close and are relatively large or reflective. If 3i Atlas had been slightly smaller or on a slightly different path, we might have missed it entirely. Yet it wasn't. It passed through the ecliptic plane, the zone we monitor most intensively at a time when our survey technology had just matured to the point of routinely finding such objects. Coincidence? Perhaps. Or perhaps, if it is a probe, being detectable is part of the point. Consider the possibility that the anomalies are the message, that the beam, the symmetry, the strange trajectory are designed to be just anomalous enough to trigger our curiosity, to make us look closer, but just ambiguous enough to allow for plausible deniability. Why would an intelligence do this? Perhaps to gauge our scientific maturity, to see if we are a species capable of recognizing and questioning anomalies. Perhaps to softly signal existence without causing the cultural shock of direct contact. Perhaps simply to make us look up and wonder, to plant a seed of cosmic perspective. I am not stating this is definitively the case. I am stating that this hypothesis fits the data as well as, if not better than, the patchwork of natural miracles required by the comet model. And it requires only one overarching assumption, that technological civilizations exist and sometimes send probes to other stars. We ourselves are on the cusp of doing this with projects like Breakthrough Starshot. Given the age and size of the galaxy, this assumption is statistically more probable than the assumption that we are alone. If such civilizations exist, finding evidence of their probes should not be shocking, it should be expected. The deeper, inescapable pattern of 3i Atlas is that every anomaly seems tuned not to stellar systems in general, but to ours specifically, to our ecliptic, our sun, our era of detection. Together, they paint a coherent picture not of a passive natural object, but of an artifact designed for interaction. And if that is true, everything changes. It means we are not alone. It means the galaxy is not a silent graveyard of dead rocks and vain biology. It means intelligence is out there, has been out there, and is perhaps watching, sampling or quietly testing. We just caught a glimpse of its handiwork passing through our backyard. And we're about to learn that this isn't an isolated incident, but part of a growing cascade of cosmic clues we can no longer afford to ignore.